Using molar mass, imagine that your class bought jelly beans, little candies, in bulk to sell by the dozen, 12 at a time, at a candy sale. You soon realize that it's too much work counting out each dozen. So instead, you decide to measure the jelly beans by mass. Okay, so jelly beans are small. You probably know jelly beans. Small little candies that are smaller than your fingernail, probably in around. So you wouldn't want to count out 12 each time. You might want to find the mass. What mass of jelly beans could you measure if a customer wants 5 dozen? The conversion factor that relates mass and dozens of jelly beans is this. There are 35 grams of jelly beans per dozen in 1 dozen. Remember, a dozen is 12. So you could do the math, right? Jelly beans per dozen, and we want 5 dozen, okay? So in the end, we want to know how many grams of jelly beans we need to make 5 dozen. So grams of jelly beans is the unit that comes at the end. It is also the unit that goes on top. The units that we have in both parts of the equation, one goes on top, one goes on bottom so that they can cancel each other out. Note how the units cancel to give you the mass of 5 dozen jelly beans. Okay, 5 times 35 is 175 grams of jelly beans. Now suppose that while working in a chemistry lab, you need 3.00 moles of manganese for a chemical reaction. How can you measure that amount? Like the 5 dozen jelly beans, the number of moles of manganese can be converted to an equivalent mass and measured on a balance. To calculate mass from the number of moles, you need to multiply the number of moles of manganese required in the reaction, 3 moles, by a conversion factor. How many grams per mole, right? We're trying to come up with grams of manganese, so we need grams on top and moles on bottom because moles will cancel with moles here. So 3.00 times 554.9 equals 165 grams of manganese are equal to 3 moles of manganese. If you measure 165 grams of manganese on a balance, you will have 3.00 moles of manganese that you need for the reaction. The reverse conversion from mass to moles also involves the molar mass as a conversion factor, but it is the inverse of the molar mass that is used. Can you explain why? So if we started with 165 grams of manganese and we wanted to figure out how many moles it is, right? We want grams to cancel. So we're going to flip this over as the inverse, okay? The inverse of this conversion factor. So instead we would write 165 grams of manganese times 1 mole of manganese per 54.9 grams of manganese. So we would end up dividing 165 by 54.9 grams and result in 3 moles of manganese. Okay, there are some practice problems and things for you to do. Conversions from mass to atoms and atoms to mass. So far you have learned how to convert mass to the number of moles and the number of moles to mass. You can go one step further and convert mass to the number of atoms. Recall the jelly beans you were selling at the candy sale. At the end of the day, you'll find that 550 grams of jelly beans are left unsold. Without counting them, can you determine how many jelly beans this is? Well, you know that 1 dozen jelly beans, 12, has a mass of 35 grams and 1 dozen contains 12 jelly beans. Thus, you can first convert 550 grams to dozens of jelly beans by using the conversion factor that relates dozens and mass. So how many grams of jelly beans? 550 grams. 1 dozen is 35 grams. So we're going to divide and we get 16 dozen jelly beans. But we can also determine how many jelly beans are in 16 dozen by multiplying by the conversion factors that relates the number of particles or jelly beans and dozens. So now we know there are 12 jelly beans per dozen. right? Not 1 dozen per 16 jelly beans, because then it wouldn't cancel. I'm sorry, 1 dozen per 12 jelly beans. It wouldn't cancel. The dozens need to cancel. So 16 times 12 is 192 jelly beans. So the 550 grams of leftover jelly beans is equal to 192 jelly beans. Just as you cannot make a direct conversion from the mass of jelly beans to the number of jelly beans, right? We cannot go from 550 grams of jelly beans times 12 jelly beans per dozen, because we don't have any way of, we're missing the dozens per gram, we're missing the grams piece, right? We need to cancel grams. So we have to do both steps. In the same way, you cannot make a direct conversion from mass to the number of particles in a substance. You must convert the mass to moles by multiplying by a conversion factor that relates mass and moles. And then you can multiply a conversion factor that relates the number of representative particles to moles, which is Avogadro's number. So in other words, you cannot go from mass to the number of particles without first doing mass to moles. So you go mass to moles. This would be like a mole, right? Except we did a dozen. And then once you get the moles, you can multiply it by Avogadro's number to get the number of actual particles in the end. Okay, well, that's a lot of math. I hope that this helps. Oh, wait, here's a little bit more. Now that you've learned and practiced conversion between mass, moles, and representative particles, you can see that the mole is at the center of these calculations. Mass must always be converted to moles before being converted to atoms, and atoms must similarly be converted to moles before calculating their mass. Figure 11.5 shows the steps to follow as you work with these conversions. Mass to moles to particles, or atoms, right? Or atoms to moles to mass. You have to do 2 conversions. In figure 11.5, mass is represented by a laboratory balance. Moles are represented by a bag or a bundle of particles, and the representative particles are represented by the contents that are spilling out of the bag. You can see that 2 steps, 1 step, 2 steps are needed to convert from mass to particles, or from particles to mass. We have to do 2 conversions, okay? So here's another example, and here they're showing how you can do it really in 1 step. If you get water, grams of water and grams of water cancel. Moles and moles cancel. So now you can do the multiplication across the top and the division of the bottom, okay? Note that the units cancel and give the answer in molecules of water. Do the reverse calculation yourself using the conversion factor pointing from left to right. So in other words, can you start with 3.34 times 10 to the 22 molecules, right? You're going to have to turn this one upside down. You're going to have to turn this one upside down. And in the end, you should end up with 1 gram of water. Give it a try. Okay, that's the end. Hope this helps.